Hello students, welcome back. Now we are going to have the hardware demonstration for our LED Blink program. In this we are going to see how does each component look like, how do we connect them, and how to power on your Arduino board and all the minute aspects related to the hardware design. So let us get our hands dirty. So students, this is how the Arduino board looks like. Here, if you observe, you can see the digital pins are from 0 to 13, then there is ground and few more pins. You have receiver RX and TX is the transmitter. Then on the other side you have A0 to A5. These are our analog pins and these are our power pins. We have two options to power this board. On this side you can plug a DC power supply, and here you can connect the USB from your laptop or your desktop. This USB port is also used to program your Arduino. When you flip this board, here you have all the solders connections which are connecting your pins as well as the microcontroller. So you should never touch them. I am touching it because right now there is no power on the board, but please make sure that when the power is given, these connections should not be touched or shorted. That means you should never keep your Arduino on a conducting surface. You should keep it on insulating surface like paper, wooden surface or a cardboard. Now let us try to power the board. I am going to give the USB from my computer here, and this is connected here. Here I have the LED Blink program dumped on this Arduino, so the internal or inbuilt LED is blinking. There is a button here which is called reset button. If you press this button, did you see there was a blink which was faster? That means the reset happened and whatever program you have, it has started again. So sometimes what happens, you are running a program, let us say a robot is going somewhere, and then you find that okay, the things are not going as planned. You can press the reset button and it will come to the beginning of your program. The second way to give the supply is through a DC. Before that, let us see what happens if I press the upload button on my IDE. So I have connected my IDE and I have a program which is LED Blink, but not at pin number 13 but at 12. So I save that program and I have to make sure about two things. One is the correct board selection. So now I have pressed the upload thing. Okay, so did you observe these? One was, it was blinking here, and the second was these two, which is receiver and transmitter from the computer. These two also blinked and showed that the uploading process was completed. I am going to upload it again. And you can see the same thing happened. Now pin number 13, which is connected with inbuilt LED, is not blinking, and you can also reset it. So the reset is working fine. Okay, now let me do one thing. I change my program back to 13 and I upload it again. So now you can see the inbuilt LED is blinking because now I have changed my program. So the second way of powering your Arduino board is through the DC supply. So I carefully take away the USB port, and this is the DC battery, and here also I have given the supply. So now you can see that it is working on 7.4 volt and the same program is running. So once we know the board, we should also know what are the components and how do we connect them. This is a resistor. It is a two-terminal device. So both of them can be exchanged. There is nothing like positive negative here. And these are the color rings. You can read these rings and calculate the value of resistance. LEDs comes in different colors and sizes. The longer pin generally is anode and the shorter is cathode, but if you cut the longer one, it may become shorter. That does not make it cathode. So you should have a closer look or maybe feel with your finger that near the cathode you will find a flat surface. So that is the identification of cathode. So how do we connect these on our breadboard? On the breadboard we had explained that there are wires. These wires, if you have internal connections, so these points from here till here, these are all internally connected, but they are not connected to the adjacent ones. So these 25 holes, or we should call them 25 ports, they are connected, and the adjacent 25 are also connected. Similarly, in the internals, 5 ports are internally shorted to each other, but adjacent they have no connection. So if you want to connect any component, you have to make sure that both the terminals should be at different potentials. So this and this, if they go like this, well, that's a good connection. But if you try like this, that means both of them are in the same row, that does not make any sense and sometimes it can damage your components. Similarly, if you connect like this, both of them are still at the same potential and that is not advised, but you can have one here and one here, that is all fine. The rule is same for resistor or any IC, any electronic component. This is how you connect. Sometimes you may have to take longer connections and the terminal lengths are not long enough. Then you need jumper wires. There are 3 types of jumper wires that we have. The first one is male to male. A male to male jumper wire is having 2 pointed connections on both the ends and they can be easily inserted in any of the pins. So now I have made a connection using the male to male jumper wire. The second one that we have is female to female. These type of jumper wires are normally connected to sensors which are having pointed pins. So they will be connected from one sensor to another sensor or from one sensor to another board pin. The third type of jumper wire that we have is male to female. So there is one pointed edge and one whole edge. So one can be on your breadboard anywhere and one can be on the sensor pin. So now you know that these are the components, this is breadboard and we have jumper wires to connect them. Let us connect the whole circuit to blink the LED now. So I have Arduino boards, I have breadboard and I'll take the components to connect them. But before that, I need something that can power my board. So here I have this DC cells. Each cell is 3.7 volts, so the total is 7.4. This one can be easily inserted here. If you want to make your own, you can purchase these in 4 AA batteries also and make a 6 volt supply, or you can have a 9 volt supply and then you have to connect this connector here so that you can connect your Arduino board. Both these Arduino boards are programmed with LED blink program to blink the LED at pin number 13 or the inbuilt pin. So I take the first one and I connect the power supply. And you can observe, first of all, the board is on and the internal LED, the inbuilt, is blinking, which is adjacent to pin number 13. Let me check what happens on the second board. I take the second board and I connect it again. So here the board is on, but the LED is not blinking. The issue was I had taken one metal screwdriver and I touched here. So the inbuilt LED was shorted and it is gone. So does that mean my board is also gone? Well, let us check it now. We are going to connect the output of pin number 13 to one LED through breadboard. And please remember, whenever you are going to connect any component on your Arduino, never keep the power on. First of all, remove the power supply. So I have removed the power supply. Now I am going to take the ground pin. So here is the ground. You should very carefully select that, or you can count also. Okay. So here is 8, 9, 10, 11, 12, this is 13 and this is ground. Okay. Be very careful when you take that. So I have taken ground here. The second thing I need is to take the output of pin number 13. So pin number 13 is the adjacent one. I connect one male to male jumper and I connect it at one more place like this. So now this all 5 pins, they are pin number 13 and these 25 pins, they are ground. After that I need to take one resistor and I connect it from pin number 13. Okay, one leg goes here and one goes here. So now from pin number 13 to any random point, I have one resistor. After that, I need to take my LED. Now you have to be careful. The LED cathode should be connected at the ground and anode should be connected to any of these 4 pins. So this is how I make the connection, and now I am going to connect my power supply and you can see the LED is glowing. So the board is not damaged, only the internal, the inbuilt LED was damaged. Now I will quickly go to the second board and connect the same and check if that one is also driving the external LED or not. So I bring it here and be very careful. Don't worry if you are spending some time in counting. So this is 8, 9, 10, 11, 12, 13. Because if you make some wrong connection and it result in short circuit, the board can be damaged. So this is how I connect, and now I connect the supply and you can see both the inbuilt LED as well as the external LED are working fine. So students, this is how you are going to connect your hardware components with Arduino. So I am sure you have learned how to connect different wires, components and everything on your Arduino board with a breadboard now. Next, we are going to discuss about DC motor control in our next video. Keep learning. Thank you.